Warm greetings. In this video, we would be knowing about artificial cardiac pacemaker and its type and mode of operation and its benefits and related risk related to the pacemaker. Contents: it contains the working of natural pacemaker and implanting a pacemaker, and the test special precautions, benefits, risk related to the pacemaker. Natural pacemaker. The sinoatrial node of the heart is known as natural pacemaker since it has the pacemaker cells which produces rhythmic impulses at a regular interval, which is known as heart rate, and it helps in the contraction of cardiac muscles known as cardiac action potential. Generally, the electrical impulses are produced in the sinoatrial node and is forwarded to the atrioventricular node and to the his bundle, and where it is spread using Purkinje's fiber. Introduction. Pacemaker, a device capable of generating artificial pacing impulses and delivering them to heart, is known as pacemaker system or pacemaker. It consists of a pulse generator and electrodes. In cardiac diseases, when the ventricular rate is too low, it can be increased to normal rate by using pacemaker. This illustration contains the examples of single chamber pacemaker and dual chamber pacemaker, where in single chamber pacemaker it has only one electrode, either it can be connected to atrial or ventricular. In dual chamber it has two electrodes that can be connected to both atrial and ventricular. And this illustration shows how a pacemaker can be implanted nearer to the heart, where the electrodes are placed inside the atrial and ventricular for the conduction of electrical impulses. Methods of stimulation. It consists of two methods known as internal and external stimulation. In internal stimulation, it prevents the normal self-triggering of the heart, and while the external stimulation is used to restart the normal rhythm of the heart in case of a cardiac standstills. Types of pacemaker. Based on the placement of pacemaker, it is consists of two types: external pacemaker and internal or implanted pacemaker. The internal pacemaker is surgically implanted beneath the skin, and while the external pacemaker is placed outside the body using wristwatch or a packet, where one wire go into the heart through the vein. The electrodes used in internal pacemaker are known as myocardial electrode, while the electrode in external pacemaker is known as endocardial electrode, and the batteries can be replaced, while the internal pacemaker generally needs a minor surgery to be done for the battery to be replaced. Any defect or adjustment in the circuit can be easily attended in the external pacemaker, while it is difficult in the internal pacemaker. For temporary heart damages, external pacemaker is suggested, and for permanent heart damages, internal pacemaker is suggested. Different modes of operation. Pacing modes of the heart can be either or competitive or non-competitive in the pacemaker. Asynchronous pacing is called as competitive because the fixed rate impulses may occur along with natural pacing, and competition with them is controlling the heartbeat. Non-competitive pacemakers are programmed either in demand or synchronized mode. Based on the modes of operation, pacemaker can be divided into five types: ventricular asynchronous pacemaker, fixed rate pacemaker, ventricular synchronous pacemaker, standby pacemaker, ventricular inhibited pacemaker, demand pacemaker, atrial synchronous pacemaker, atrial sequential ventricular inhibited pacemaker. Ventricular asynchronous pacemaker, it can be implemented in atrial or ventricular, suitable for the patients who are suffered by total AV block or atrial arrhythmia. It consists of square wave generator and monostable vibrator. The period of square wave generator is given as T equal to minus 2 RC ln 1 minus alpha plus divided by 1 plus alpha, where alpha is equal to 2R by 2 R1 plus R2, and it is known as feedback voltage fraction in the circuit. The disadvantages is heartbeat rate cannot be changed. If it is fixed in atrium beat at a fixed rate. If ventricular beat at a different rate, and then it leads to severe problem, ventricular fibrillation may be occurred. Ventricular synchronous pacemaker suitable for the patients who are suffered by short period of AV block. Electrode placed in the right ventricle of heart. This electrode is used to sense R wave. If ventricular contractions are absent, then the pacemaker provides the paces. This type of pacemaker does not compete with the normal activity. Electrode is used to detect the heart rate, and it is given to the amplifier and filter circuit. Because the heart rate amplitude is very low, amplifier is used to amplify the cardiac signal. Filter is used to remove the unwanted noise signal. Signal is given to the refractory grid control and timing circuit. R wave is below the certain level. At the time only, this pacemaker will deliver the paces. This is an example of PQRS wave detection on ECG exam, where the QRS complex is detected in the ventricular synchronous pacemaker. The advantages involved in this pacemaker are ventricular fibrillation is avoided. When R wave is normal, then the fixed rate pacemaker block is not on condition, so power consumption is reduced. Disadvantages are very sensitive to electromagnetic interfaces, no synchronization between atrial and ventricular contraction. Ventricular inhibitor pacemaker. In this pacemaker, it is known as demand pacemaker. And comparator determines the phasing rate of the pulse generator. The output is given to second RC network. The pulse width circuit determines the duration of the stimulating pulses. Rate limiting circuit disables the comparator for a short time interval and limits the pacing rate. Output circuit provides a voltage pulse to stimulate the heart. Voltage monitor circuit senses the cell's depletion and controls the rate slowdown circuit and energy compensation circuit. The rate slowdown circuit shuts off some current to the basic timing to slow down the pulse rate during cell depletion. Energy compensation circuit uses the pulse duration unit to increase the battery voltage when it decreases, and it is used to supply the energy to heart. Sensing circuit detects spontaneous R wave and resets the oscillator timing capacitor. Reversion circuit helps the amplifier to detect the spontaneous R wave in the presence of low level continuous wave interference. In the absence of R wave, the circuit allows the oscillator to produce pacing pulses at its present rate. The inhibitor pacemaker allows the heart to pace at its normal rate when it is able to do so. And the rate slowdown circuit shuts off some current to the timing circuit to slow down 8 plus or minus 3 beats per minute during cell depletion. This is the block diagram of ventricular inhibitor pacemaker. If the R wave is missing for a preset period of time, then the pacemaker will turn on and provide the heart a stimulus. Hence, it is known as demand pacemaker. Atrial synchronous pacemaker. P wave is sensed and picked up by the electrode placed on the atrium. It is given to the amplifier circuit. Amplifier circuit is used to amplify P waveform. Circuit is used to give the delay of 0.12 seconds, and the output of the delay circuit given to the refractory control and preset multi-vibrator block. If the P wave amplitude is not in the normal wave value, then fixed rate pacemaker will turn on. If the P wave amplitude is normal, then the fixed rate pacemaker is off. If the fixed rate pacemaker is on, then the output is given to the amplifier and the amplitude signal is given to the ventricular through the electrode. If the rate of atrial excitation becomes too fast or too slow, a preset fixed rate pacemaker is used. And where in the atrial synchronous pacemaker is a SA node is input is taken from the SA node, and the pulses are given to the ventricular through electrode. Atrial sequential ventricular inhibitor pacemaker. It is used to simulate both atrial and ventriculars. It is a demand pacemaker, so it is based on the patient's need. It provides the pulses. In the modern pacemaker, magnet is placed over the pacemaker on the skin of the patient. This magnet is used to activate reed switch. This switch switches the pacemaker to any one of the mode of operation, either to give impulse for atrial or ventricular. And then the tests involved in the placement of pacemaker are electrocardiogram, ECG or EKG, Holter monitoring, as similar to the monitoring of heartbeats using smartwatches. Echocardiogram senses the electrical impulses of using sounds, and stress test. Special precautions: while the pacemaker is placed or implanted in the human body, some precautions need to be taken, such as the cell phone should be placed at 15 cm. Security systems detect the pacemaker due to the titanium metal used in it, and medical equipment cannot be used when it involves laser treatment or the kidney stone treatments, and the persons using the pacemakers should be away from the power generating equipments. Then the benefits: by keeping the heart from beating too slow or too fast, pacemaker can treat symptoms like fatigue, lightheadedness, fainting, palpitations, and etc. It can allow to get back to a more active lifestyle by automatically adjusting the heart rate to match the level of activity. Risk: when it is implanted, it can lead to bleeding or formation of a blood clot where it is placed, or damage to the adjacent structures such as tendons, nerves, muscles present in the area, or damage to the causes dangerous arrhythmia where it produces irregular heartbeats to the heart. References. Thank you.